Gravity is the force that attracts other objects to each other. Every object in the universe attracts every other object in the universe. I attract that house. That house attracts me. I attract every tree in that forest. Every tree in that forest attracts me. It's the law of universal gravitation! Now you may be asking yourself, how is that possible? Well, it's possible because of matter! Ugh. You see, everything in the universe is made of stuff called matter. So mass is the amount of matter in an object. An object's mass is generally constant. And something you might be a little bit more familiar with is the concept of weight. Now weight is the force of gravity on an object. The greater your mass, the greater the force of gravity on you. That's it. So going back to what I said before about the law of universal gravitation, anything that has mass, that is matter, attracts other things that have mass and matter. That goes for planets as well. Here's the kicker though. Your mass might be constant, but your weight, not necessarily so much. Because weight depends on the force of gravity acting upon you. And that can depend on a few things, like where you are. Now the Earth is a heck of a lot bigger than we are. Many millions of times bigger than we are. So Earth has a tremendous pull of gravity on us. That's why when we jump up, we fall back down to the Earth. We do exert a force of gravity on the Earth, but we're so small, we don't even notice. See, the moon is smaller than the Earth. That's why when astronauts go to the moon, they can jump really high, they can hit golf balls a really long way. It's incredible. It's all because of gravity.
In summary, because the Earth is larger than the Moon, a person standing on Earth's surface experiences a greater force of gravity than an astronaut with the same mass walking on the Moon. The less gravity exerted on us, the less we weigh.
So I figure, if I want to lose weight, I don't have to diet or eat less or anything like that, or do anything creative. I just have to go to the moon. Right? Does anyone know the phone number for NASA? The strength of gravity also depends on how close two things are. For example, see that tree over there? I'm standing decently far away from that tree. So now I'm twice as far away from the tree as I was before. So I exert half the gravity on that tree, and that tree exerts half the gravity on me. When distance decreases, the force of gravity increases. When distance increases, the force of gravity decreases. The strength of gravity depends on the distance of two objects. Where are you going? So another important force that you have to understand is inertia. Now, inertia is based off Newton's first two laws of motion. An object at rest will stay at rest unless a force is applied. An object in motion will stay in motion in the same direction unless a force is applied. So, my hope is that those things will allow me to pull this tablecloth out without knocking any of these cups over. So as the previous exercise demonstrated, inertia is an object's tendency to resist a change in motion. In this case, the plastic bowls are trying to resist a change in motion caused when you try to pull the tablecloth out from under them. That's inertia. Things want to stay still if they can. But what about objects that are already moving? Please consider the following. Now the moon, represented by this apple, and the Earth, represented by the squash, exert forces of gravity on one another. The Earth has more mass. The moon has less mass. The Earth exerts a greater gravitational force on the moon than the moon does on it. But that leads us to a new question. Why doesn't the moon simply go crashing into the Earth? We can answer that question by thinking a little bit more deeply about what's going on with the moon. The moon is not sitting motionless out there. If it was up to the moon, it would have zoomed off into space a long time ago. The moon has velocity. So while the moon experiences a strong pull of gravity from the Earth, it also experiences movement on its own. It wants to go places. So that's why the moon simply goes around the Earth, because of its velocity acting against Earth's gravity. It's inertia and gravity working together! If the moon had any greater velocity than it has, it may in fact zoom off into space. If it had less velocity than it actually has, then it might go crashing into the Earth. It's a delicate balance. Just like the force of gravity on the dishware allows the dishes to stay on the table when you pull the tablecloth off, The velocity of the moon keeps it from going crashing into the Earth. They're different examples of inertia.
To be fair, just as the moon would fly off into space without the Earth's gravity, the Earth and the other large planetary bodies experience the same relationship with our massive sun. And just as this sort of balance results in the moon's orbit around Earth, the planets revolve around the sun for the same reason. Not all orbits are the same, however, because the planets all exist at different distances from the sun. The period of revolution for a planet is how long it takes the planet to orbit around the sun. The farther away a planet is from the sun, the farther it has to travel when it circles the sun, and the longer its period of revolution will be. Thank you for considering the following.
Hey, you can't be in the show.